artifacts are items like articles, blog posts, videos, or any other URL. Each of these sites has their own metrics for calculating the popularity score of the artifacts. Web Artifact Popularity Checker is an approach which computes a single aggregate score across different media. You may be wondering how useful it can be. See, we want to compute a score of an artifact that reflects the popularity of an artifact across different social media sites and not just limited to any particular site. Say for example, the publicity team of a company may want to know the popularity score of its advertisement video across the social media and see how people are reacting to it. Or any content creator company which creates and shares its content on different social media sites will get to know the popularity score and get feedback about the content. As Facebook and Twitter are the leading social media sites and is generally the first choice for content creators, ad agencies, freelancers, etc. to share their content, we would be focusing on computing the social score for artifacts shared on Facebook and Twitter only. For this, the main challenges are an artifact could have been shared by different people and across different sites. So we have to aggregate artifacts from multiple resources and compute a combined score obtained for each of the artifacts. There will be many posts and tweets where people discuss and talk about an artifact, but they do not always code the artifacts. Ideally, these tweets and posts should also contribute to the popularity of the artifact. For example, the Mauka Mauka ad video became very famous on social media during the ICC World Cup. And many people shared it on multiple sites and people talked about it for length without necessarily quoting the video link in every post and tweet. So after having sufficient background, let's move to the actual problem statement. For given data sets of Facebook and Twitter crawl data, we would compute the popularity score of all the artifacts present in the data sets. We will compute this score by aggregating not only the tweets and posts which have quoted the artifacts, but also the tweets and posts which talk about the artifact and assign a combined score obtained for each of them. So here's the basic flowchart. We crawl the Facebook and Twitter dataset to get the JSON files. These files are then parsed to get various artifacts and non-artifacts. Then we apply these two methods, indexing and k-nearest neighbor, to get the score. We also tried clustering with k-means, but the results were not that good, so we continued with these two methods. For more detail, refer to the report given in the video description. Next is approach. A naive approach could have been simply summing up the likes, shares and comments for Facebook and summing up favorites and retweets for Twitter to get the score. But this is not the correct approach, so we have used a more sophisticated model. It includes following steps. First is gathering data. We crawl the Facebook and Twitter pages. For crawling Facebook data, we use the Python Facebook SDK, which uses Graph API. And for downloading the data in JSON format, for Twitter, we use the Java library Twitter4j, which downloads the data in JSON format. Pre-processing data. For extracting the text from artifacts, we use HTML to text tool. The output is then tokenized, and all punctuation marks and special characters are removed. For this, Python NLTK tokenizer has been used. After tokenizing, we performed stop word removal and stemming. The stop word removal step removes a lot of noise and also reduces the dimensions of text. Stemming helps mitigate effects of tense and other grammatical correctness, which is really not a concern for text processing tasks. Now let's have a detailed look on the approaches we have used. We constructed vector representations for each artifact. Using these TF-IDF vectors, we trained the KNN classifier in an unsupervised way. Now let's consider the non-artifact post. We also converted the text of non-artifacts to TF-IDF using the same vocabulary as in training. As a final step, we have computed the top 10 closest neighbors for each non-artifact and then calculated the respective similarity scores. Now, given a non-artifact, we consider that this non-artifact may be talking about the 10 artifacts that we get as results of KNN. So for every artifact in the results of KNN, we update its likes, shares and comments count as follows, where new count is equal to old count plus normalized similarity score into count of non-artifact. In this formula, the count refers to the like, share, comment count of an artifact, old count refers to the original naive count of the artifacts, and new count is the count for every artifact after adding their respective non-artifact score. Next is indexing. We take the text of the artifacts and put them in a directory for indexing such that each file contains the text of each artifact. We use Lucene for indexing the data. All non-artifacts are then queried against the indexed files and 10 most closest documents per query are retrieved. So for every artifact or document in the results of indexing, we update its likes, shares and comments count as follows. New count equal to old count plus normalized similarity score into count of non-artifact. The terms used are having similar meaning as explained before. So the final score, we have calculated the combined likes, shares, comments count for each artifact. All we have to do now is to compute a total score. For Facebook, we have used the following formula: x into number of likes plus y into number of comments plus z into number of shares. And for Twitter, we have used x into number of favorites plus y into number of comments plus z into number of retweets. Here x, y, z are constants which act as weights for each of the associated count. In our experiments, we have used x equal to 1, y equal to 2 and z equal to 5, thus giving more importance to shares and retweets and comments compared to likes and favorites. Now let's see the demo. We crawl Twitter and Facebook to get data in JSON format. Here is the sample JSON file for Twitter. All the necessary codes required to run the entire program are put together in a bash file as shown. The first section, as you can see, is for extracting data out of the downloaded JSON files and making the artifact, non-artifact files ready. Here is the artifact file, and here you can see the non-artifact file. Then the next section of the code is for KNN approach and Java code for Lucene indexing. Here you can see this second part: Python code for KNN and Java code for Lucene indexing. Both the approaches give us the top 10 documents for each artifact corresponding to each non-artifact. These are the non-artifacts queried. We are having the top 10 artifacts corresponding to them along with their similarity score. This is the result corresponding to KNN. Here this corresponds to the non-artifact. This is the artifact ID, and these are the score of the artifact ID. Similar result can be found for indexing. This is for Facebook non-artifacts. After this step, corresponding data is generated in files which are then read, and the data from them are put in a database. This happens in the third part. From the populated database, the corresponding scores are also calculated, and the results are stored in a text file as will be shown. In this file, the artifacts are arranged in descending order of their score. Let me demonstrate the results. As mentioned before, the dataset we crawled is about ICC Cricket World Cup. Ideally, the most popular artifact should be about Australia winning the World Cup. As a matter of fact, in both our methods, this artifact came out to be the top scorer. It can be seen easily. See the first link here. We can copy it and can see the results. Here we are getting dominant Australia lifts World Cup for 5th time. And this link is similar in both KNN result as well as indexing result. The second spot differed in the KNN results and index results, but for both the approaches, top results that differed from each other were within short distances from one another. A post about Sri Lankan cricketers retiring also got a high score from both and was within top 5 artifacts. See here. This result corresponds to the indexing part, and this link is similar to the KNN result as a This is also expected because legends like Sana Jayasuriya and Kumar Sangakkara were retiring, and many people shared this artifact and talked about it. As we have already seen that our first link was as expected, as the most popular artifact was Australia winning the World Cup. Before seeing the results, we thought that the famous Mauka Mauka ad from Star India would also be one of the highest scored artifacts, but it wasn't the case. As a matter of fact, it was not in top 20 from either methods. This may be due to the reason that although the series of ads were very common and talked about in India, for the rest of the cricket playing nations it was not so. As output, we will be providing two files from two different approaches we tried, KNN and indexing. The format will be artifact and social score for each of the artifacts for both the methods. Presently, we are crawling the past data and then applying our algorithm. We can extend this to make it more dynamic, as every second hundreds of new tweets and posts come up on Twitter and Facebook respectively. Better techniques for data crawling could be used. Presently, there are some links from which we could not crawl the content due to the error need cookies to access this website. We'll incorporate a decay factor while calculating the social score to ensure that the most relevant information influences the computed popularity to an appropriate degree, because the popularity of an artifact may fluctuate over time. While computing the score of an artifact, if any verified user tweets or shares an artifact, then we could give more importance and weightage to these posts while calculating the overall score of the web artifact. Better techniques for data crawling could be used. Presently, there are some links from which we could not crawl the content because of cookie issues. Thank you. For any feedback or suggestions, you can contact us.